You ask a company's chatbot a simple question, "What's your refund policy?" And it answers, instantly, no hesitation. 30 days, full refund, no questions asked. There's just one problem. None of it is real. The bot never looked anything up. It just made it sound right. So how do you get an AI to stop guessing and actually check its facts first? The fix has a name you've probably scrolled right past. It's called RAG. Retrieval-Augmented Generation. Let's open it up. To see why it bluffed, picture how a language model learns. It reads a huge slice of the internet once. Everything it picks up gets baked in, frozen at a cutoff date. After that, the book is closed. So every question is a closed book exam. Whatever it studied, it can answer. But your refund policy was never in that book. Neither was anything that happened yesterday. And here's the trap. The model is never rewarded for saying, "I don't know." It's trained to sound right, so it writes something fluent, confident, and sometimes completely invented. That's a hallucination, a good guess with no source. So here's the fix. It's almost silly how simple it is. Before the model answers, you let it open the book. That's the whole idea behind RAG. 2 steps, right there in the name. First, retrieval. Go find the pages that actually matter. Search the real documents, pull out the few about refunds. Then, generation. The part it always did. Write the answer. But now you hand it those real pages first, tucked into the question. Read these, then answer. Same model, same question. But now it's an open book exam. Reading the actual policy instead of guessing. But that hides a sneaky question. Out of thousands of pages, how does it find the right ones? Not by matching words. That's the clever part. A small model turns each page's meaning into a list of numbers, a vector embedding. Picture it as a point in a space of meaning. Similar ideas land near each other, like books on the same shelf. Store every point in a vector database, indexed to find neighbors fast. Your question gets its own embedding too, and the database pulls the closest points. That's nearest neighbor search. What we're really after is semantic similarity, how close two things are in meaning, and the common way to measure it is cosine similarity. Draw each point as an arrow from the center and check the angle between them. Tiny angle, nearly the same meaning. Wide angle, unrelated. Other measures exist, plane distance, dot products, but they all score one thing. How close in meaning? Which is why refund can pull a page that says money back guarantee with not one word in common. Searching by meaning, not by spelling. So let's watch the whole thing run. You ask a question. It gets its embedding. The vector database hands back the nearest neighbors. Those pages get pasted into the prompt. The model reads them and writes the answer. And working from real documents, it can show you where each fact came from, a source you can click. This is running quietly under tools you already use. It's how an answer engine cites sources from this morning. How a notebook app answers questions about your own files. How a support bot finally quotes the policy that actually exists. No retraining, no new model. Just embed, retrieve, and read the right page. But before you trust it, one catch. RAG is only as good as the page it grabs. Hand it the right document, and it's brilliant. But if the search pulls the wrong one, an outdated policy, the wrong customer's file, the model reads that just as happily and gives you the wrong answer with the exact same confidence as the right one. An open book exam only helps if you're handed the right book. So most of the real work in RAG isn't the writing. It's making the search find the truth. So that's RAG. It doesn't make the model smarter. It makes it look things up before it speaks. It swaps guessing for memory, for checking the page. And once you've seen it, you'll spot it everywhere. Every time an AI answers with a source, every time it somehow knows about today. A closed book turned into an open one. Turns out, that's most of what it takes to make an AI you can trust. Thanks for learning. See you in the next one.